Yes, please.
All right. Can you bring the presentation back?
I just did Neeraj. Yeah, please go ahead.
All right. Thank you. Thank you. Good morning, good afternoon, good evening, everybody. Thank you for joining our sessions today on Azure Talk. In past, we have conducted more than 35 sessions, and today we have been we are going to cover Azure DataBrick, and today we are joined by our team from
Syllable Technologies. Syllable Technologies.
Syllable Technology, and we have Anupam and Ayush, who is going to walk us through DataBrick session. And many of you know, I'm Neeraj Kumar, and I'm a Microsoft certified trainer, enterprise architect, working for one of the big four firms as a cloud architect. And today, as I said, we'll talk about the Azure DataBrick session. And in case if you want to refer our old sessions, the sessions that we have done in past, you can head over to www.cloudeasy.com/AzureTalk.html. Additionally, you can also subscribe to our YouTube channel, which is youtube.com/c/AzureTalk. We also have our own forum, which is IM Instant Messenger chat-based forum. So you can join that forum too, and the URL for that is t.me/AzureTalk. So with that, I'm going to hand over the session to Ayush. So maybe Lalit can go ahead and make Ayush presenter, or
Sure, I'll do that.
Yeah, make Ayush the presenter. I'll do some of the talking initially, and then Ayush will take over after that. But Ayush is the one who'll be running through the slides.
Sure, I'll just make the presenter to Ayush.
Okay.
Thanks, Perfect. Yeah. Can you see my screen?
Not yet. You started sharing?
Yeah.
Yeah, it's coming up. It's coming up.
Okay.
Perfect. All right, everyone. So just a quick background about us. So we are Syllable Technologies. We are a Microsoft Azure partner and a BizSpark Plus startup to build solutions on Azure. And happy to be part of this Azure Talk series, which probably is one of the most popular series on educating the community on Azure capabilities and different technologies. I'm Anupam Gupta. I'm President US Operations for Syllable Tech. My background has been in data warehousing, BI, and big data systems. And I have with me my colleague, Ayush Bijawat, who's a Azure data engineer at Syllable Technologies. So let's quickly get into it. Just a couple of slides to give you the background. We don't want this to be a big data overview, but just to start with some background. Big data, the term has been quite popular already. It's been around. Hadoop is the most common big data technology that everybody is aware of. It's been around for almost decade and a half overall. Prime need for big data processing is to have high volume of data, different varieties of data, structured, unstructured, and processing them at a very fast pace. So there is velocity as well. So with the growth of internet and other devices, we have petabytes of data flowing in, both structured and unstructured. And the only possible way to analyze that has been through distributed processing, but in a way that the analysis still stays consistent. And that's where Hadoop has proven to be successful. Next slide, please. So a bit of history of Hadoop. A lot of the early research and innovation came from Google, and Google published a couple of white papers, both on the file system, the Google file system, which became the foundation of or the inspiration for Hadoop file system, and the MapReduce, which is more of a programming paradigm for a fault-tolerant, consistent, and resilient data processing over distributed commodity systems. Yahoo was one of the early companies who started innovating heavily, besides Google, on big data processing, and also started contributing to Hadoop open source project. And then a lot of other players joined in. We use the term Hadoop commonly, but it is comprising of these two aspects: the storage, the file system, which is distributed, and then the programming paradigm, which is MapReduce. So some of the things that Hadoop was able to prove and achieve was to have horizontal scale out capabilities, that you just keep adding systems in a distributed landscape, and you could scale out in terms of adding more and more data, at the same time not impacting significantly the overall performance, and leverage massively parallel processing and distribution and things like that. It was purely based on commodity hardware, so you're not buying huge servers. I mean, companies like Google and Yahoo, even if they wanted, they couldn't buy those scale of servers in those times that could manage this level of scale. So horizontal scale out over commodity systems was one way to do it. At the same time, this whole paradigm ensures that this distributed processing is fairly efficient and reliable. Reliable in the sense like you have commodity failures, but you have some redundancy in the system, so those failures are taken care of. Next slide, please. So a few things where Hadoop was a success. It was, it proved the concept of distributed processing on commodity hardware, right? It proved that this kind of scalability is possible, right? If someone like Google has to, or Yahoo has to index the whole internet, every day, distribution is the only way to go, right? And so is true for, other use cases applied on this kind of large data sets. It's resilient to failure, so there is redundancy built in. So one node fails or one commodity hardware fails, you have system shifting the load to another one. Besides the structured data where relational databases have been doing the job, there is a lot of text, audio, video, graph data, images. All that also needed analysis, and that's where Hadoop also scored over the conventional structured systems or relational database systems. But there are certain areas where Hadoop was lacking. It wasn't very conducive for low latency workloads. So if I have to run a quick query to analyze, let's say, certain kind of optimization or profitability reporting, it may run, but it'll take few minutes, if not sometimes more than that, to execute. So you are sure that you can do this kind of analysis on large data sets, but it's not something you can give to a business analyst or a data scientist to easily analyze them in a real time, right? And it was found that the problem is not so much on the file system, but it's the programming paradigm, which is more suited for batch processing, right? So almost every large organization has, big data scenarios, and they all started some form of prototyping and, trying out at least one or two use cases. And one of the things they found out is the technology is still quite complex. A lot of effort was put in to manage these clusters. Of course, a lot of it was open source and evolving, so that was part of the problem. But on the whole, things were fairly complicated. It did not offer in-memory capabilities, which nowadays is very popular with relational databases and MPP systems. So that was another challenge, not having real-time processing. So, and consequently, you can't do streaming data sets. If you cannot do fast iterations, you won't be able to do machine learning kind of use cases, which involve a lot of iterative processing. So there are some of the success points, and then there are a lot of limitations. Next slide. And then came Apache Spark. So Apache Spark started as a Berkeley AmpLab project, and the same guys who started Spark ended up founding DataBricks later on. And Spark tried to counter some of the challenges of Hadoop. So, try to make things more real-time, add more in-memory capabilities, make things more supported, the more mainstream languages for an easy support, and then develop some kind of a content in the form of machine learning libraries, graph capabilities, etc., and streaming capabilities onto this unified data engine. Now, as a concept, Spark was very promising, so a lot of people joined the bandwagon and to start contributing towards the growth of Spark. It became a very popular open source project. Some of the largest organizations, search engines, internet companies started adopting Spark with thousands of node clusters. So basic areas where Spark started scoring over Hadoop was the overall processing time and the simplification of applying different programming paradigms and languages, etc., onto the big data distributed system. Next slide. So in a nutshell, Spark is easy and fast big data. Of course, that's a very blanket statement. But yes, speed-wise, Spark definitely made things more real-time. So you could give it to an analyst to find trends. You could give it to somebody who's doing some basic statistical analysis or machine learning to run those computations over large data sets. And the promise of Spark was that you'll have a unified engine for all your data processing needs, right? So you want to have large data stored and you want to do some kind of warehousing and run SQL queries. You want to do machine learning, you want to do graph data processing, you want to do event stream processing of certain kind of on a streaming IoT data. At the same time, preserving the whole linear scalability and fault tolerance concept of Hadoop. Right, so those principles were intact. You still could horizontally scale out by adding more nodes and keep adding more data sets and processing to it. But doing those things in a fairly fast and low latency manner. Next slide. So DataBricks, as I mentioned, was a company founded by the folks who created Apache Spark. And it, of course, grew out of AmpLab project at UC Berkeley, and they, founded this company and started making more formal distributions of Spark and give it a more enterprise overlay, if you will. The initial offerings from DataBricks for Spark were on AWS. So the idea was that you could procure these Spark clusters by click of a button, and you have these notebooks to run these commands and process data, as opposed to having a plethora of open source tools and struggle with those. So they tried to organize it almost like a enterprise product. And it's been around for a couple of years. There's been widespread adoption. So just like in the Hadoop world, you have open source Hadoop, but you have companies like Cloudera and Hortonworks supporting with their own distributions and own contributions, and putting a whole enterprise layer on top of it. So same thing DataBrick started doing for Spark, but I haven't seen them deviate a lot from the standard Spark distributions. They just, so it's not kind of a forking that we have seen in the Hadoop world, but more of adding enterprise capabilities earlier in the AWS and now in the Azure offerings. And that's what we are here to talk about.
So Anupam, Neeraj, I have a question.
Sure.
So is this a platform as a service offering on Azure, or it's a set of VMs that will get deployed when I deploy Databricks?
A set of VMs will get deployed, but I would still call it more closer to a platform, given the kind of capabilities it offers and the kind of integrations it offers. So I would say it's somewhere in the middle, because you end up doing the clusters, but the whole process of those clusters and all is fairly abstracted, so you can focus more on your data management and processing rather than managing those clusters.
Okay.
So it's not SaaS in the
managed.
So clusters are managed by this whole application that you set up, but it's not fully transparent also. Like I wouldn't call it like a SaaS-based SQL platform. It's not going to be like that. So you still have clusters running.
Okay.
It's just that the whole offering makes procuring and managing those clusters simple, as you would see. So on one hand, Databricks gives a unified processing engine to do all kinds of workloads, your ETLs or ELT as you call them nowadays, your SQL queries. We have something called Spark SQL. Machine learning, we have machine learning libraries, and so on and so forth. At the same time, you have this unified experience in the form of notebooks. You have dashboards and reporting capabilities also, right? Now, the concept of notebooks has been around. We all familiar with Jupyter notebooks, which the Python community and Python machine learning community uses extensively. They're very popular in the Azure world. You had something called Zeppelin, which became popular with the Spark use cases. It's not very common these days, but Databricks has their own set of notebooks or notebook capability to perform these different data operations, right from writing code in different languages like Scala, Python, R, Spark SQL, to having D3 kind of graph capabilities, which is something we'll demonstrate. So you have the engine, but at the same time, what it was lacking earlier was some kind of a enterprise interface or to communicate, the processing and data manipulation that you're doing. Next slide.
Anupam, Lalit here. So
Yeah,
as you can see, it's just doing an analytics. So it is in all kind of the analytics, like it will help the financial organization to analyze their data, and to the other organization that which product is more the people is utilizing, either the location wise or how it is.
absolutely.
Right.
Absolutely. And so see, simple SQL processing, there are a lot of tools who can do that, right? But imagine having, let's say, some unstructured data set, right? Somebody gave you certain logs, right? Now your simple SQL won't be able to analyze it, right? You won't be able to do those SQL joins. But if you have the access of programming language like Scala or Python, and you are able to read those kind of data sets which may not be very structured, or you are able to manipulate those data sets all on the fly. And now you have this whole computing power that's pretty much running in memory. It can be scaled up as much as you need. I mean, scale out, but having larger data to be churned. That is like a best of both worlds, right? And you mentioned financial industry, but yeah, any industry that has large data sets and they want to have this kind of a fast analysis without involving a large what do you say, IT cycle, right? That, okay, we'll write the ETL jobs and then we'll transport them and then we'll test them and all that. So this is something that gives you to do a quick and dirty analysis, right? So let's say I'm sitting with the supply chain lead of the organization, right? Now he says, yeah, I have this inventory data lying and then I have some other marketing data line, right? Can you correlate and tell me what my trends have been, how my trade spending has been performing, right? I have this, data I purchased from a point of sale company like Dun and Bradstreet or something like that, right? So you have these data sets. Some of them may be in a relational database. Some of them may be in the form of files. Now, if you have this kind of environment, you write a couple of command lines, you pull the data quickly into your Spark environment, analyze it, visualize it, communicate to your boss, right? Even do some basic machine learning and find some kind of statistical patterns there and find insights. The same thing doing in Hadoop world was possible, but very cumbersome, slow, and required a lot of technologies which were not that friendly. Does that answer your question?
Yeah.
Okay.
Thank you.
So, yeah, I wouldn't go into too many details of Azure. We have been doing, there are almost 33, 34 sessions in Azure Talks itself. So it suffices to say that it's probably the fastest growing enterprise cloud that is. In my personal opinion, Microsoft Azure is perhaps the only complete cloud. And the reason I say that is because probably the only company who has right from a data center to productivity tools, right? Like you have on one side things like Power BI, Office 365, SharePoint, and on the other hand, you had the whole infrastructure capabilities and data centers and networks across the globe, right? And a lot of products and solutions in between, which have already been adopted by the enterprise over the last couple of decades. So it would be a very good combination if you could have something like Databricks on Azure. And that's what happened on the last quarter of 2017, where these two companies had this joint offering. And now you have a Databricks offering on Azure. Now, already Databricks, the objective was to give kind of an enterprise flavor to this open source capability, right? And they've taken it to the next level with their Azure partnership, right? So you have an enterprise grade big data platform, right? And the key point here is you have these Azure enterprise services where Databricks seamlessly integrates, simple things like Active Directory, right? So you want authentications in your organization and you don't want to spend time doing those if you do a Hadoop landscape, right? You want Power BI integration, right? Yes, you can do a quick and dirty analysis in your notebooks. Certain advanced users and analysts can play around, but that's not something you're going to communicate to your average business users. Whatever the final output of your findings, you want to be able to communicate via an enterprise BI tool. And so that's where Power BI integrates with the Databricks Spark. At the same time, it can pull data and send data to blob storage, SQL data warehouse, SQL server, etc. And these integrations help because you can do the big data analysis, but if you want to use a proper structured data warehouse or a database, you can send that final process data into these structured systems, enterprise systems. Interactive workspace, which is the concept of notebooks and dashboards that we'll showcase today, that enables this whole powerful collaboration between a community of data scientists, data engineers, and business analysts. Now, this is a very profound statement that these three different roles coming together, single interface to perform these tasks. Now, I imagine the scenario where you're sitting in kind of a war room, you have this data from different sources, you just ran a campaign and you are getting some kind of point of sale information from the market, you get these files and you quickly start churning the numbers and communicating with each other, right? So that's kind of the promise of Databricks capability on Azure. And of course, the whole procurement becomes faster in terms of setting up clusters, enhancing them, and so on. Moving on. So this kind of a detailed comparison, I'm not going to go point by point, but there are a lot of things which the traditional open source Spark may not present, but Azure Databricks platform offers those capabilities, and most of them make this whole enterprise adoption much more easier, right? So like running multiple versions of Spark, supporting, Parquet format, kind of, data formats, things like auto scaling, better visualizations, more granular access and, statistics on the kind of usage you are having. Because internally, as Neeraj asked earlier also, you end up using the Azure infrastructure. So any kind of capabilities to monitor Azure, they would lend themselves to the Databricks landscape as well. Moving on. So yeah, this is a very important slide to visually showcase what this whole landscape is. So it gives you the capability to tap into different kinds of file storage, structured, unstructured, etc. And then you have this whole unified runtime. And it gives you an interface that makes things fairly serverless. I wouldn't call it like a fully blown platform as a service, but it comes close to that. Because you do have virtual machines running it as a distributed sort of a cluster environment, but it is fairly abstracted from the users and the developers working on it. And then you have these different applications or workloads for which you can utilize this. So Spark has taken, and Databricks has taken, best of many worlds into one data platform, right? You have the scalability of a data lake. At the same time, you have a low latency of a fast MPP system, right? So you have, best of both worlds happening. And then you have a lot of capabilities to do machine learning, analysis, Spark SQL, etc. And these different languages that it supports, that brings more and more people to the platform with whatever programming they have been doing. Somebody is more familiar with a functional programming language like Scala. If somebody is, of course, there's a huge Python and R community that is supported. And then the Spark SQL is fairly close to ANSI SQL and getting closer every day to support those set operations that people are comfortable with. Next slide. And all of this possible with the proper enterprise compliance in terms of security, logs, etc. So that's been one of the key factors. Because one of the challenge for enterprises to adopt these open source tools is, are they well regulated? How can we control this whole enterprise compliance thing? And that is where this Azure and Databricks partnership really gels very well to give it a full-fledged sort of enterprise stamp. So these are the popular Azure services which I mentioned, where Databricks taps into or integrates with. That gives a very interesting combination to choose from, right? So if you're already using SQL Data Warehouse, you already have some data in SQL Server, you can pull in from there the just a single command. Once you process it, you have the Power BI integration. Somebody dumps the files on your blob storage, you can quickly pick them up and start analyzing, right? Some of these points I already mentioned in terms of integration, enterprise grade security, Active Directory integration, visualization of its own capabilities, as well as Power BI. Next slide.
Right. Anupam, here's some questions from the audience. So
Okay.
Ashish has a question that it is a alternative platform to SD Insight.
Yes. So it is an alternate to SD Insight. See, there are a couple of competing technologies within Azure. And it's an evolving scenario right now because Azure partnered with Hortonworks for HD Insight. That was their Hadoop offering. And there have been benefits and there have been challenges of HD Insight. I don't want to get into that. That probably calls for another session. But yes, I would say it's an alternate. It's not something that is integrating with that or relating to that. It would be an alternate for a big data scenario.
Okay, thanks, Anupam. And one more question
Sure.
is raised by Banker is it is like how it is different from Azure Data Lake Analytics.
Yes, that's a very good question. I don't know if we have a slide for that, but I think we do. We are covering one use case where we have given both the landscape. If you would do it using the conventional Azure Data Lake Analytics, and if you would do the same thing in Databricks. So I'll talk about that.
Sure.
In fact, we have even implemented one scenario where we are doing, for one of the customers, we are doing it both ways. And then we'll weigh out the pros and cons.
Sure.
So I'll talk about it. Yeah.
Yes.
So key features, again, this is pretty much repetition, but yeah, we'll get into all these details. So you have the concept of workspaces, notebooks, clusters, monitoring jobs, visualization capabilities, custom visualization capabilities. So it's, as you see, it's kind of mixing the whole open source philosophy, tapping into D3J libraries and Java, Python, Scala, Python, etc. At the same time, being in the enterprise world. So there is this concept of workspace, and I won't get into details. I would leave it to Ayush as he goes for the demo. But Ayush, you want to start with some demo right away, or you want to go? Let me go to the use cases first. How do you want to do it?
Yeah, we can do it with the use case and then I'll present a demo.
Okay, so I'll quickly go through the slides so that you can rather see these things in the demo itself rather than me talking. So workspace is a way of organizing these notebooks and folders, etc. And you can even import more cutting edge libraries of these programming languages and so on. Next one. So we'll see the actual working version of this, but as you see there, the notebooks are supporting, different languages from Scala to R to Spark SQL. Next, actually that was Python, sorry. Yeah. Auto scaling, auto termination. So in the below the hood, it is the same VMs that are working, but they have done a better job of abstracting that and as much auto scaling features they can add. See, it is not something natively built in Azure, but they have done their best to hide all the sort of the nuts and bolts and have this abstracted layer for you to manage and scale the cluster. My personal opinion, I have found this to be more cost effective, and it's not a personal opinion, you can check out the facts, to be much more cost effective and easier to manage than some of the Hadoop offerings that you find in the enterprise world. Next slide. That's fine. So you can set up these jobs, etc. Visualization capabilities, you would rather see them in the actual dashboard that Ayush will cover. Custom D3 capabilities that you can add. Yeah, so this is just to summarize the differentiating factors, how the Azure partnership helps. So, you have, enhance productivity. You can collaborate better with notebooks. Imagine you do some analysis and quickly send the link of your notebook to your boss or to your colleague. Or let's say you are a data engineer, you do something and then you send the same notebook link to a data scientist who can take it from there. That, okay, I have loaded the files, now you do your magic on top of it, and things like that. It's a compliance, taking care of the security. And of course, all the SLAs and the compliance features of Azure would benefit Databricks deployed on top of Azure, right? And again, scaling without limits, in the sense like you can keep growing the cluster to very large number. Next slide. So this is a very generic slide talking about the different capabilities or big data capabilities. I have purposely kept HD Insight out of it because Hadoop is kind of an alternate to Spark. The HD Insight offering would be an alternate to the Databricks. I don't see a scenario where you would have both of them. Having said that, it's not impossible, but you wouldn't have two commodity-based distributed systems of this nature in the same landscape, right? So you have, we probably should have added DataLike onto this, but that's fine. So you have these structured and unstructured data feeds coming in. You have the Azure Data Factory helping you with the procurement, things going into SQL Data Warehouse or blob storage, and then the processing. If it's simple SQL, you can connect your Power BI directly to SQL Warehouse. If it needs some more structuring of data, you can do it in Spark via Databricks and then push it to Data Warehouse, or you could even do certain analysis on Databricks directly and communicate via Power BI or the whole Databricks dashboards, notebooks, etc. And same thing with SQL Server if you want to communicate something. And this also could be bidirectional. We don't have the bidirectional arrow for SQL Server, but yes, it can both send and pull data from SQL Server as one of the scenarios that we will show that we have also done that. Next slide. Yeah, over to you, Ayush.
Yeah, thanks, Anupam. Okay, so I'll start with briefly describing how actually the Azure Databricks portal looks like. So while we're talking about workspace, this is where we can see that it provides a collaborative environment where the multiple users can have their dashboards or notebooks or the external libraries that they want to add for multiple languages that they support. Along with it, it provides a privacy that the user want to share his notebooks or the dashboards with her as well. Okay. When we talk about cluster, one thing I personally like about Databricks is when we were using traditional Apache Spark, we all have to do a manual setting up a cluster of downloading and setting up and all. So this has made our life quite easy. By just clicks, we are able to create a new cluster with features like auto scaling and auto termination to avoid the unnecessary wastage of services and the costing as well. Okay. Okay, so just like Jupyter Notebooks, Databricks have got its own notebook. So we can write our code, and for a particular use case, we have this Scala code for a data pipeline that I'll showcase to you right now. So before starting the code, I'll just like to mention that we can add our notebooks to any cluster running in our environment. So just want to click on this button and we can detach or attach this particular cluster to this particular notebooks. So for the scenario, what we are doing, I'll give a brief overview that we are pulling the data from Azure blob, and we are applying some orchestration and data wrangling over it, and then we are pushing it and writing it to the DBFS via applying some Spark SQL queries over it to get some visualization hands-on right while we are processing it. So from this particular space, we can see that we are setting up the required credential access required for the Azure blob, and then we are applying the transformation to the loaded data in the Spark to add a custom column which is being extracted from the file name itself, which is mentioned here. So that particular custom column is being added in this step. Similarly, we are applying the current date as this particular column in the data frame, and similarly some constant strings which the customer required to add in the particular columns. For removing the deduplication, we are using some Spark SQL queries over it. So you can see that these queries are quite fast to execute right here in the notebooks, and we can see the data as well. And some user-defined functions which are being done using Scala practice, and all the transformation that is being. Finally, we have applied Spark SQL joins over the brand mapping lookup table and the unique master table to create a final output result that is into the data frame. And then we are actually visualizing our values through Spark SQL queries and creating visuals right here in the notebooks. So you can see we are analyzing for different months what are the units sold and what are the sales. And by hovering it to the point, we are actually getting the figures out of it. Similarly, we are also mentioning the units sold in a particular fiscal years, and so on and so forth. And finally, we are writing that data frame to the DBFS. Okay. We can apply the similar scenario using Python as well. So we had applied the same. I'll just show the same.
So Scala is the most popular language in the Spark community. A lot of the Spark code has been written in Scala itself. But Python also being popular in general in the data science and data wrangling community. So we tried achieving the same thing using both these languages in different notebooks. So the idea we are demonstrating here is usually you need 3-4 different products or technologies to run these kind of jobs: data procurement, doing this data wrangling, cleaning up, deduplication, analysis. All of it you can do with a single window, right? Applying these different things in a collaborative environment. So maybe different people writing these different sets of code, but since it's all web-based notebook, you can share notebooks, you can apply your own logic through your own notebook, etc., and immediately see the results rather than waiting a long cycle, right? So that's like the power of this capability.
Right, and also we can entangle this views and visualization into a particular dashboard and see it in a separate window as well. We can also apply Spark machine learning libraries over it to visualize our data. We have applied the same in one of our scenarios as well. Yeah, this one. So what actually we are doing in this scenario is, similarly, we are pulling the data from a blob, and then we are extracting the features out of it to make the machine learning model of it, And before doing this, we are actually cleansing the data, so some string or null columns is being clarified from it, and we are splitting the data into two sets, one for the training and the other for the testing, and then similarly creating a machine learning model and then predicting the values for it. So these are the sales figures and between the actual and the predicted one. You can run all your steps in one go and see the result right here. And for checking the logs and cluster information, you can go for the Spark UI logs that are being actually present. So you can actually check how the processing is being done, which commands are being executed, whether it is action or transformation, and also the DAG, which is being a key feature of Apache Spark to get the directed acyclic transformation that is being done in this scenario. So this is how the data is being transformed and analyzed, and also machine learning predictions can be done, and later we can save the same in DBFS. And if you want to check for UI purpose, DBFS provides a portal here itself to see that the file that is being write using Spark SQL or Python or R scripts. That was part of the demo. So a brief overview of the scenario that was being done. It was actually a point of sales data analysis. So we are pulling that data from Azure Blob Storage. We are applying some transformation on it. We are creating the master tables and removing the deduplication using Spark SQL, and then applying Spark SQL joins on the data set and writing it to the DBFS. Further creating visualization and dashboards out of it for generating better insights.
Yeah, Ayush. So as I discussed earlier, there are two architecture options, and there could be a third one using HD Insight also. But these are sort of competing technologies, capabilities in Azure. So the first one is doing this using the DataBrick scenario, and then another using the Azure Data Lake, right? And this is responding to also the question about, how is it different from the Azure Data Lake, right? So this is the Databricks where you can do ingestion, also you can do streaming ingestion, you can do all kinds of analysis and processing, manipulate the data sets, and then visually communicate or send it to another data warehouse or a database, right? Going to the second version of the same problem, if you use the whole data lake analytics paradigm. See, data lake analytics internally uses the Hadoop distributed file system, and it uses a version of MapReduce itself, or I think it does use MapReduce with a layer of USQL written on top of it. So what Microsoft did was also to make this whole data manipulation simpler. They enabled a language called USQL, which also allows you to use certain C# libraries for complex data manipulations, etc., which we have been implementing for our customers as well. But again, the challenge is data lake analytics end of the day would not be very low latency thing because of MapReduce, right? And also it would have limited use cases. You would not use it for running SQL queries. I mean, you can run these queries, USQL queries, but that's not where it is, most suited for. It's suited for doing data manipulations, part of a pipeline, cleansing, deduplication, and those kind of things. And then once you do that preparation, you again push it to a warehouse or a database, and then you perform all the other aspects of it. Azure Machine Learning is Microsoft's Azure's capability of machine learning. There are multiple areas where we can do machine learning. Of course, Hadoop SD Insight has its own. You can do nowadays in SQL 2016, 2017 also. You have embedded R and Python engines there. The whole, Revolution R capability. And in Databricks, you would be able to do using the Databricks, the Spark ML libraries on the notebooks itself. So these two, I would say, are alternate technologies. They both have pros and cons. Azure Data Lake Analytics, you can say it's more simplified. Some people would not want to go with DataBricks and have this cluster and all that. So, and of course, DataBricks has been new. So Data Lake Analytics has been around for a while. Now, this is a more, again, a detailed comparison between these scenarios and what different services can be involved. Some of the things, I would say DataBricks is fairly self-sufficient to perform different aspects of data engine, right? And in case of overall Azure landscape, you have these different small pieces to perform those different tasks. Having said that, they can be used in conjunction with each other or in isolation. So we have more options now. Simply put, we have different areas to do the same task, and we can pick and choose based on our use case. This is another quick analysis we did. So we had this SAP data in SQL Server, and of course you can do modeling and analysis, but we thought, okay, let's quickly pull it to DataBricks and see if we can do some forecasting and reporting and that kind of a quick and dirty analysis out of it, right? So the way I see it as, it's like Excel on steroids, right? People typically do a lot of quick and dirty analysis in their spreadsheets, right? They don't wait to put the data in a database and making things formal, writing their own macros quickly and showing something to their boss, right? Of course, Databricks is a lot more, and Spark is a lot more than a spreadsheet, but just by the nature of it, it gives you that analysis. So I don't know if you guys know about this mode 1 and mode 2 capabilities that Gartner proposes, that you have the mode 1 analysis, which is the whole structured data warehouse landscape, which is more IT managed, very formal. You have to test things before moving them to production. And then you have this mode 2 where business teams want to quickly analyze the data. They don't want to wait for IT to run through this whole DevOps cycle and, because see, this is not the source of truth. You're not manipulating the transactional data or anything. You're just picking the data from transactional systems and other areas and doing a quick analysis. So you want to be more self-reliant, just like a spreadsheet, to do this analysis. So that's the kind of analysis we have showcased with this particular use case. Yeah, go ahead, Ayush. Yeah, so these are the dashboards we put together. Again, these are not to compete with the Power BI capabilities. You're welcome to use Power BI, obviously. But this is just real time. You just loaded the data. You just brought up some quick dashboards. You can share the link with your boss, and that's it. So just to summarize, Azure Databricks is a unified platform to satisfy data engineers, data scientists, and business analysts. It's now built on Azure Cloud Platform, which is a secure and most, I would say, enterprise-ready platform. You have more and more content being added through the Spark community. So there are more machine learning libraries being added, which offer distributed capabilities, which rather exploit the whole parallelization of Spark processing. So you can have machine learning faster. A lower cost. One of the challenges with HD Insight was it was fairly expensive, and there was no way to pause it when you're not using it. So you pretty much end up shutting down the server, and you would have to reset it up. Whereas in Databricks now, you could just pause it, and you don't pay for you only pay for the storage, obviously. You don't pay for the compute. And you can bring it up in a couple of minutes whenever you want to use it, right? That's the whole promise of cloud, right? The on-demand computing access, right? So that's where Databricks is also going to be helpful. And at the same time, being very organized, right? So just because it is open source and you have this cluster-based scenario, does not mean it is ad hoc or it's very technical. So you have these notebooks and dashboard capabilities and workspaces, etc. And multiple programming languages supported. So there's a wider community you can bring on for the same data set. I guess that's the end of it. So are there any more questions or comments or feedback?
Thanks, Anupam, for a nice session. Let me just unmute all the participants. If they have any questions, they can, directly put the questions. Okay. I'm just unmuting all the participants. So guys, do you have any questions, anything, just, raise your hand and, you can get and ask questions from Anupam and the team. It has presented on Azure database, which is, has been a really nice session and the tool which is, only will be utilizing by most of the organizations and all, and will help, to analysis, a quick analysis, and to running in some other organizations. I think basically a data organizations, for them this will, help you much to, analyze your data and all. So I have unmute all the participants. So if you have any questions, any queries, please, uh, raise your voice or raise your questions.
Yeah, Anupam, this is Mahapati. Yeah, is there any free trial or any can we explore more about that database in Azure itself? Can we get rid of any subscription or something for this?
Yes. So what we are doing is we are not paying for any Databricks subscription on this. There is a trial version to do that. Of course, you end up paying for the compute and storage, the Azure resources that you have to pay. There is also a way to do it on a local machine. I'm not too sure. Ayush, can you elaborate on that? The different trial capabilities?
Yeah, for basic trying purpose, we can go with the community version that Databricks provide. So you can deploy a single cluster over it, not more than that, but all the transformation regarding those languages can be done easily on it.
Is there any dependency like OS dependency or something?
No, it all runs on the cloud. So you just have to log in with the browser and access the cluster.
Yeah, Anupam said like you can do with the like a standalone also.
Okay, Ayush, is there a standalone capability at all? I know the community is still to be installed on the Azure. Maybe there is for the Spark. I'm not sure for Databricks.
Okay.
But we can explore that. But yeah, fairly. I haven't seen it on Windows. I mean, typically these clusters are all Linux-based clusters. There could be VM environments that are ready-made that you could download for basic Spark to play around with Spark capabilities and notebooks. I'm not sure if Databricks has a local environment or not, but we can check and we can respond on the Azure Talks, the Telegram forum that we have.
Okay. And just add into the Anupam's answer, like even though if you can utilize your free subscription, which is there in Azure, so you have an sub credit for 1 month, which you can create a services and that utilize your Azure Databricks. So what are the services you wanted to explore, which will help you to get in more details on that.
Right. So anybody coming from the Hadoop background, I would highly recommend start looking into Spark and Databricks, because that's the natural progression going forward. And all the major Hadoop vendors also have some kind of a Spark offering now with Cloudera, Hortonworks, etc. So they are all warming up to Spark now.
Right. So anybody has any?
Anupam, yeah, one more question. I don't know whether it is right or wrong. So I'm just asking: Is it can we use the Spark or Azure Databricks? Can we use it SAP BO? Is it will work?
I haven't seen direct connectivity of SAP BO, and SAP BO is a wider area. So are you talking about Universe or Webby or Lumira or what particular tool? But I don't have any information of Spark connecting to those, but we can find out. Do you have a use case where you would want to connect it to that?
No, the use case is nothing but like can we see? Can we give that to the customer to? Can we? Why don't you go for because customer is looking for they want to switch over to SAP BU or to Azure Databricks or else Spark something. That's what I'm asking.
You mean if the customer already has BO and they
Yes,
would want
the
to...
customer is already using a BO. The customer is looking for alternate options. That's what I'm asking. So first, if they want to go for alternate solutions, first they need to migrate everything. So that's what I'm asking. Do you have any use case for that?
See, in my personal opinion, a lot of these BO tools are fairly antiquated now, right? So the modern BI tools are things like Power BI, Tableau, Spotfire, ClickView, and these all pretty much connect with Spark, right? They all have connectors for Spark. BO traditionally, the universe, etc., is meant for a relational database. So you'll have a two-step process to move data from Spark or Databricks to a SQL server or something, and then do the universes on top of it, right?
Okay, you mean to say I need to migrate the data to Spark SQL or else I need to use it in Microsoft SQL? I don't know that the Spark SQL will run it for the Microsoft SQL server or some other.
Spark SQL will run on Spark, and then you move the data to SQL Server. From there, your BO connection will work.
Okay.
Yes. Anybody has any other questions? So before we wind up, just if anybody has any questions, you can I have unmuted all the participants. They can ask the questions, and then we'll wind up the session.
So just one comment I would like to make. So we at Syllable, specialize more on the big data, machine learning capabilities of Azure. So if you guys have any topics which you would want to suggest, there are other things we plan to cover, like Azure machine learning and analytics capabilities. But besides that, if you have any ideas, which specifically relating to data, we would love to know, and then cover those in the future sessions.
Sure. Thanks, Anupam, and yeah, please.
Again, this Mahapati, see, if you sorry to ask the question again. So if you have any use case, just share it to me, or else you can share it to the portal itself. For use case, I'm asking about migration for SAP BO to Spark SQL.
So basically,
see, SAP BO it's a reporting tool, right?
Yes.
Yeah, Spark SQL is a SQL capability that you can do set operations in Spark. Spark by itself is not like a modeling and visualization tool. Either it would rely on those D3 graphics or notebooks or dashboards, or it would connect to Power BI or Tableau or Zoom data or those kind of tools to do the visualization.
right.
Okay.
Right? So it would not be a one-to-one comparison.
So basically, as I know Anupam has already described in the architect design. So you have those analytics tool, whatever the Spark or the whatever the tool is told, and then you have an data into the SQL Server which is connected to either the data would be stored in your storage account or in the SQL Server or any database which is connected to your Spark, which will analytics your data, and then these reports can be sent to your Power BI for your dashboard views and all. Uh, Correct me, Anupam, if I'm
Okay.
wrong.
Yeah, absolutely.
Yeah, I can understand. Thanks.
Okay. So,
So guys, feel free to give your feedback either on the Azure Talk group or you can message us personally on the Azure Talk as well, the Telegram group. And thanks for the opportunity of having us here. We like to share what we are working on, which is very exciting these days in the Azure ecosystem. There's so many changes happening, so always good to interact with the group.
thanks, Anupam. Thanks, Anupam and Ayush, for have a nice demo and the nice session over here. And thank you so much, all the participants who is continuously joining and encouraging Azure Talk as a free learning. And it's been a best Azure learning for the Azure platform. It's been more than 33 sessions which we have conducted, and you guys has love it and learning from Azure Talk. And even though the few feedbacks which I would share, the people, when I just ask few of my colleagues and someone, okay, do you know Azure Talk? They say, yes, I know Azure Talk. So thank you
Oh
so
yeah,
much.
it's very popular already.
Yeah,
We
Right.
have like
Yeah.
close to 3,000 people now.
right. So thank you so much for being, be a part of community. And yes, yes. Any feedback you wanted to share? Anybody? Okay. So I'm just, winding up the session over here. Thank you so much for joining the session, and have a nice day. Good
Yeah,
evening, good morning, and
Thanks.
good night. Yeah,
thank you. And I trust you'll be uploading it to our YouTube channel, right?
yep. That will be uploaded.
Okay. All right. Thank you. Thanks, everyone. Bye-bye.
Thank you.
Thanks, everyone.